Hello, hello. My dishwasher just made a loud explosive sound. Um, Today I thought I would show you Garam puzzles. Garam puzzles, I'm not quite sure what they're called. This is a puzzle that a friend of mine showed me a while ago. I think they're quite fun, they're quite interesting. It doesn't seem too well known, so I thought I'd do a little video to show it off. We're just going to start off on medium and work our way up as far as we can go. So the way it works is you have to fill in numbers 1 or 0 through 9 in each box such that each equation that you can read vertically or horizontally going from left to right and top to bottom is sensible and works. So this is the medium one, so there's quite a few ones that we can kind of attack directly, so we might as well start in the top left. So this number we know has to be 4 or less, because if it was 5 or greater, the answer would be a 2-digit number, which can't fit into this spot. We also know that that number times some number gives you a number starting with 30. So I have the timetables up here. It would be nice if we just had a 9x9 timetable, but whatever. Hopefully we won't get distracted by unnecessary things. So we know that there's kind of an upper limit on what both of these can be. But let's look at this. Something times 3 equals a number starting in 10. So if we look down, we're looking at either 12, 15, or 18. So this is 4, 5, or 6. But we know that it can't be 5 or 6 because of this restriction. So this has to be 4, meaning this is 12. That makes this 9, as we know. So 9 times something is 30 something. And if we look in our 9 times table, that we know it's 36. That being 9 times 4. 4 minus 0 is 4. 2 plus 4 is 6. 2. 5. 5 times 4 is 40 something. So we know this is either 8 or 9. But if it was 9, 9 plus 1 is a 2-digit number, so we know this has to be 8. This is 40. This is therefore 1. 3 plus something equals a number ending in 1. Well, we know it has to be 11 because there's no way that we can add two numbers to get 21 of these. So this is 8. This is therefore 9. Over here we have 9 plus 4 equals 13. 9 minus something equals something. That number plus 2 equals a 2-digit number. Okay, so this is either 0 or 1, right? Because if it was 2, we would get 9, we would get 7 here. 7 plus 2 is not a 2-digit number. So this is either 0 or 1. So this is a feature we'll probably use more in the other difficulties to put in both of these, just to kind of like keep it in place. And therefore this is either going to be 9 or 8. This is probably unnecessary. I just wanted to kind of show off this superposition feature where you're putting in two possible numbers, just because it becomes, at least for me, extremely useful. So therefore this is either 3 or 2. But we can see that if we had 2 minus 3, we'd get negative 1 here, right? Which is obviously impossible. So this has to be 3, meaning this has to be 0. Whoops. Meaning this has to be 8. Meaning this has to be 1. Easy peasy. So this is 0. So we know this is 7. 7 times 9 is 63. 0. So 7 plus 3 is 10. All right, not that hard, but a good little warm-up. So hopefully you get the idea. You can kind of see some of the strategies and stuff you use, but it's just going to get much, much more interesting. Okay, so what sort of things can we attack here? 8 plus some number, 2-digit number. Okay. Sometimes 2 is a 1-digit number. So again, we're looking at 4 through 0. Could be good. Something plus 2, and that same thing times something equals 30 something. Okay. something plus something equals, so we know this has to be 15. There's no way it's 25. So that's quite restrictive. It's 9 plus 6 or 8 plus 7, right? Those are the only ones it can be. If it was 8 plus 7, then neither of these plus 3 could be a one-digit number, so we know it's 9 plus 6. And we know it has to be in that order, because if 9 was here again, we wouldn't be able to make that number. So something times 9 is 30-something, so we know that's 4 times 9 is 36. 4 plus 2 is 6. You know this is something there. So this has to be 5 and up. It's good to know. And then this has to be 6 or less, okay? Which is, that doesn't actually restrict us too much. So something times 9, something times something is 9, and something times something is 40-something. So this can be 9 times 1 or 3 times 3. But if we look in the 3 times table, we see that we can't get up to the 40s column, right? So we know it must be 9 times 1. And then here we have 9 times 5 is 45. 5 minus 0 is 5. This one is pretty awkward because it's just 0 plus something equals a one-digit number. So we know this has to be less than 8, or 8 or less, that is. We know this times... Okay, so like let's say this is 0, and then this is 8. Well, that works. Okay, let's see. Maybe we should restrict ourselves somewhere else first. Okay. So we know this has to be 4 or less, meaning this has to be if it was... Nah, that's not what you're doing. So if this is 4 or less, then, well, let's put it in here. 4, 3, 2, 1, 0. And then therefore 6, 5, 4, 3, 2, 1, 0. It won't even let me put in that many. Let's see. What else can we look at here? 8 plus something is a two-digit number. So this is either, this is 2 and up. Numbers that end in 7. This actually seems like it's quite restrictive. So it's either 9 times 3, or that's it. This has to be 9 times 3 in some order to be 27, right? There's nothing else that ends in 7. It can't be this, of course. So we have 9 and 3 in some order here. If this was 9 up here, then this would have to be 1 for this to be a one-digit number. And we know this can't be 1 because there's nothing times 2 that equals 1. So this has to be the 3. Oops. This has to be the 9. Oops. So 3 times something equals a one-digit number. That times 2 equals. So we know it has to be 2. It can't be 4 because that's a two-digit number. It could be 0. So it's either 2 or 0. Actually, though, we know it can't be 0 because then we have 0 times 8 equals a two-digit number. So we know this is 2. This is therefore 6. This is therefore 1. This is 5. This is 9. 6 times 8, 48. 7 times 1, good, good. This is 9 there. So this is 17. Okay, we're quite close. 0 plus something equals something, that plus 8 equals something. This minus this is 7. So this this can either be 0, 1, 2, 3, or not, no, 0, 1, 2. Okay. Meaning that this is 9, 8, 7. So, what times 4 gives us things that end in a 2-digit number with 9, 8, 7? It looks like it's only 28. Okay, so that's 4 times 7. So this would be 7. 28 minus 1. This is 1. This is 1. All right, sweet. We did it. Not too bad either. How's my timer looking? Okay, that's when I gotta go get my laundry up. Let's try advanced now. Okay. This looks pretty good to start with. Maybe. Yeah, let's take a look at this. Okay, so two numbers multiplied together equals a number starting in 1. There's quite a bit. We know this is at least 2. This is at that's 9. We know this. We can always put that in. Look at this progress. This one is pretty restrictive, actually. So this is either 8 or 9, meaning that this is either 1 or 0. All right. So then this is either 0 or 3. But is there anything that actually multiplies to 43? I don't believe so. I believe that is prime. Okay. So we know this is 40. Therefore, this is 0. Therefore, this is 8. Okay. That's good. We know that 8 plus something is a 1-digit number. So this is either 0, 1, meaning that this is either 8 or 9. But we know it's 8 because this is 8 times 5 equals 40. So this is 8 plus 0. So therefore this is 6. Something times 6 is a 1-digit number. So that's either going to be 1 or 0. Therefore this is either going to be 0 or 6. So therefore, well, this could be all sorts of things. And this could still be all sorts of things. Let's look what's going on here. This is going to be 4 or less, but this is going to be at least 5. That's not too restrictive. This is going to be at least 1. Okay, that's not too restrictive. This, something plus something equals either 10 or 11. That's quite open. But then this plus 0. All right, so let's work on this, I guess, because there's actually maybe not as many as I think. This can either be 5 times 2. And we know this, okay, this can't be 0, so this actually has to be higher than 2. So if it's 5 times 2, the 5 has to go there, and the 2 would have to go there. It could also be 4 times 4 for 16. And there's nothing else that factors into 16, right? It's only 4 times 4. So therefore, this is either 2 or 3. And this is also either 2 or 4. Meaning that this, well, because this can either be 10 or 11, this could then be like anything from 6 to 9, I guess. Right? With like kind of inner restrictions. So that's maybe not worth worrying about yet. So this is 2 or 3, meaning that this is either, this is like 7, 8, or 9. Oh, wait, what? Oh no! Well, this doesn't make sense! Okay. um, so this has to be, so this is less than 5, 4, 3, 2, 1, 0. And this is more than, so therefore this has to be 6 and up. Okay. So if this is 6 and up, then this has to be, oh god. Oh, something's terribly wrong. Oh, I know what it is. I'm an idiot. This could also be 8 times 2. And I think that's what it has to be. So the 8 goes here, the 2 goes here. Yeah, okay, alright, whew! So then this is 6. Okay, alright. Jeez. See, okay, like, I'm really, I like, don't have my times tables that memorized. So I wanted to have this up here, so I could just remember quickly. But then it's like, if I look at it, and I don't actually, like, fully look at it, then I'm not actually, like, thinking to myself. Like, I'm just looking at the table. So if I miss something on the table, like this, which in retrospect is obvious, then it's like, I don't actually go through the things in my head, you know? You know what I'm saying? It's very sad. Okay, so this is either 8 or 9. I'm not quite sure how we resolve that yet. Oh, we know this is 1. Sorry. Yeah. So this is definitely 9. Okay. So something plus 6 is a 2-digit number. But then we know, okay, so we know it has to be 4, because otherwise this would be a 2-digit number. But it's not, it's 8. So this is 11, this is 1, this is 4. Something times 4 is a single-digit number, so this is either 0, 1, or 2. And this is therefore either 0, 4, or 8. Okay. If this is 0, 1, or 2, then we know this has to be either, well, it can't actually be 0, because there's nothing plus 0 as a 2-digit number. So this is actually either just 4 or 8. Good, good. Therefore, this is 8 or 9, and this is 0 or 1. But we know it can't be 0 because this is at least 1, so this is 1. This is, this has to be 9 plus 2 then. This is 8. This is 2. Sweet. And this is 4. Okay, great. Do we have time for one more? Well, we should, but we're getting into difficult, so let's see. Let's see how it goes. Okay. Something times 3 is a 1-digit number. That's not, that's kind of restrictive. That's 4. I might as well put those in. 1, 2, 3. 0, 1, 2, 3. And then this is either 0, 3, 6, or 9. To get something times that equals a number starting in 30, we know it's not 0, that's for sure. So this is also not 0. If we look down at our 3, it's not going to be 3 either, because there's no... so looking at 6, this could be... 6 times 6 is 36, so 6 can go in here. And then this could be 6 times 5 is 30, so 5 can go in there. And if we look at 9, it can be 9 times 4, so 4 can go in here. And therefore, this is either 3, 4, or 5. Okay. So if this is either going to be 30, 36. I guess that's it, right? 9, we get 36. 6, we get 30 and 36. Okay. So, let's see. So this has to be 8 or 9. Or 7. Meaning that this is going to be 0, 1, or 2. So if it's 0, 1, or 2, minus something equals 0 or 6, then this can't be 6. So this is 30. So this means that this has to be 6. This has to be 5, 30. This has to be 0. Minus 0 is 0, meaning that this has to be 2. This has to be 8. All right, sweet. We're making pretty good progress. Don't want to get too ahead of myself, though. Something plus something is a number starting in 10. This has to be at least 7, so that's actually quite restrictive. This is 7, 8, or 9. And then therefore this is also 0, 1, or 2. So something plus something equals 17, 18, or 19. That's still pretty open. Well, it can't be 19. We know it can't be 19 because there's no two single-digit numbers that add up to 19. So we can get rid of that, meaning we can get rid of 2. This is going to be at least... Well, we know this actually has to be quite a bit bigger than 2. So it can be like 9 plus 6, 9 plus 7, 9 plus 8. 9 plus, it's a lot. Okay. I don't think we can make much progress there. This is actually pretty restrictive. This can either be 0, 1, 2, 3. Okay. And then therefore this is either 0, 3, 6, 9. Oops. Just as we were doing up there in the top corner. So again, we actually know a lot of these are no good. 0 and 3 are no good. Therefore, 0 and 1 are no good. So I kind of feel like maybe let's take a look here now. So for 2 and 3, we have 2 times 5 is 10. So this could be a 1. This could be a 5. And then that's it. For 3, 3 times 7 is 21. So this could also be a 2. And this could be a 7. Okay. That seems pretty good to me. So this therefore could be 7 or 9. And then this would have to be thus 9 or 8. Yeah. Couldn't be 7. Yeah, okay. Because if it was 7, then 7 plus 7 is not one of these. 7 plus 9 is not one of these either. Okay. So we're not quite there yet, but all of this will fall like a house of cards once we figure out what's going on here, which is also pretty restricted. So 6, it can either be 30 or 36, so this is 0 or 6. And then 9, as we know, could also either be 36. So therefore, this is either 5, 6, or 4. We know this isn't 6 because then this would be a 2-digit number. So we know this is 30, meaning, whoa, this is 6. This is, oops, 5. Therefore, this is 2. Therefore, this is 2 times 5 is 10. Yeah, that's the only thing it could be. And then this is 17. making it so this has to be not. This has to be 7. Sorry. I mean, no, that's fine. Yeah, this is 9. I mean, this is 8. I mean. Crisis. Oh crap. Okay, let's undo a bunch and then see what we're looking at. Okay, how solid? What was going on here again? This is kind of the downside of using the pencil marks of putting in the things you know it has to be one of, is that like you don't necessarily remember why. Like I don't know like what part of this logic to kind of attack to try to figure out where I screwed up. Let's see. So we can let's assume that everything I've solidly put in right now is right, and try to work from there. Actually, let's take a break. We'll come back to this later, and hopefully something will kind of enlighten us. Because I see something up here that's actually pretty restrictive. So 4 starts to become a 2-digit number. So this has to be 3. Yeah, because if it was any higher, this would be a 2-digit number. So this is 9. This is 12. Okay. A little bit of progress. This is going to be at most 2, right? 0, 1, 2. So if we look at our 9 times table, the only time we see something that low is 72, 9 times 8. So we know this has to be 72. And this is 0. Great! So this also has to be 0. This has to be 0 as well. Then this has to be 0. No! Oh, what? Oh! What is this? What is this? Okay, so this logic to me is like very simple. I know all of this must be fine, right? This has to be 3, assuming this is 4. This has to be 9. This has to be 12. Okay, this is all just based on this being 4. This has to be 72, right? There's no surprises there. Oh, it could be 9 times 9 is 81. Why didn't I see that? Why didn't I see that before? Because I am a fool. Okay, so then this is 1. Then this is either 0 or 1. And this is either 0 or 1. And then this is any number. Any dang number. But, you know, that's fine. Because then this is all good. This is all good. Okay. 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 That was pretty scary for a second, but we're okay. Okay, so well this can be 0, yeah. So this has to be 1 as well. I mean this has to be 0. Okay. So let's try to do this again. Maybe we just made a mistake before. The 6 and 9 we saw many times before can be 0 or 6, right? We're doing 6, 0, or 6, right? Then in 9, only 6. So this is 5, 6, or 4. And then this is also 5, 6, or 4. And then this, oh yeah, okay, so this is what we were thinking before. This can't be 6. This has to be 0. This has to be 5. But that's not, well, no, it's fine. This could be 5 times 9. So let's kind of go at it from this direction. But I have a sneaking suspicion that something is going to go wrong here. Alright, this is all looking fine so far. So this has to be 5 times 2 is 10. This has to be 7 minus 7 is 0. And then this has to be 9 plus 8 is 17. Oh, 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 oh no. Oh no. Oh no. Oh no, what is happening? Okay, Where did we go wrong? Where did we go wrong? Oh no. Oh no. Oh no. Okay, so let's just try to like make some changes and see if we can make something that works again. No, this can't be right. Unless this is 1. Then this would be, I mean, obviously, 8, 9, okay, okay, and then this would be therefore 3, oops, and then this is 8, and then this is 9. Oh, okay, alright, so somewhere up here, we made some incorrect assumption. I don't know what, I don't remember at all what. But it all worked out. I just had to fiddle around a little bit. I knew we were close. Like, I knew it wasn't that we were, like, totally off, I think. I think if we were totally off, we would have run into lots of other problems. Okay, so we'll end this episode now, but we'll try pushing into very difficult, expert, fiendish, master, and see if we can make any progress. It's fun though, right? I think it's pretty cool. It's very satisfying. These sorts of difficulties, I don't think they're that hard, but they're fun. It's still very satisfying. And then once we get into these difficulties, you'll see the limits of my intellect. But yeah, I guess we'll probably do that tomorrow.